quickly, I'll share the presentation just to begin for today. Sunil is already there. Welcome, Sunil. Thank you so much for joining.
Thank you.
Can all of you see my screen? Can you see my screen?
Yes, yes.
Thank you so much. Okay, so today is the second day. The rules remain the same. All of you are now familiar with the rules, so I'm not repeating the rules again. But ensure as far as possible that your mics are muted and video is off. In case you wish to unmute it, then you should only wait when we ask you to unmute. It gets unmuted, please mute it again. And as I have said, that on the last day, that's on Saturday, you will have to undertake a quiz. You will have to score 4 on 10 to at least 4 on 10 to get the certificate. And I'll request all of you to go through the presentation that has already been shared with you. Now, a couple of questions, a few questions that came our way. So I thought I'll just first take up those questions before we start the session. So since Sunil is also with us, Sunil, I have shared this question, the first question that was there, that was on the links that you had shared. So they had some problem in working on with those links. Would you like to respond to that?
I tried to, but not right to the conclusion. I tried opening the link to set up the show and many options. Actually, see, if you open that link, there are plenty of data. Okay, so you have to do some homework to sift through the data and arrive at this thing, because that's actually meteorological data. So meteorological data will have n number of parameters. You have precipitation, you got humidity, you got temperature, you got yearly averages, you got average over decades, average over days. In that particular year, you will have average rainfall of every day. So we have to go through the lot of data and get the. Okay, so it will be very difficult for me to actually go into that sheet and actually start explaining. That will take itself about to actually for each and every data. So my suggestion is, if you are unable to make out anything out of that link, just go to metadata or just Google rainfall data in say Patna or Bihar, wherever you are. Just say rainfall, last year rainfall in the year 2017, take the data and work with that. Okay, that would be the easiest thing to do. If you are unable to make out anything out of that link what I shared, just in Google type rainfall data 2016, whatever number you get, you start working from that. Okay, so that will be better.
Thank you, Sunil. The second question, in fact, I had asked my colleague Ranjana. Ranjana, if you have joined, can you please unmute yourself and respond to this, how to determine the catchment area of pond or a dam?
Yes, thank you. Good evening, Fawzia. I have joined, and good evening all the participants. It is wonderful to see that you have already started your calculations and you want to know how to go about it. So if we are talking in terms of the catchment area of a pond, now what is generally done is we prepare a contour map. So when we say that we prepare a contour map, contour is different elevation, different heights in an area, and we try and locate, all right, from this area the water can come because of the level difference between the highest and the lowest level. So the pond in any area is at the lowest level in that particular area. And if you are asking me what possibly can be the catchment area can be 2 square kilometers. That is the maximum for a pond. But in case of a dam, of course, it is a much larger area. In case of a dam, most of us have been to hill stations. So if you are talking in terms of the Nainital Lake, then from the highest elevation of the nearby mountain, all the water will come down to the depression which happens to be the Nainital Lake, and so that catchment area has to be taken. So what I'm trying to tell you is that we have to first locate the highest elevation in that area and the lowest elevation, because it is in the lowest elevation that all the water will accumulate. But for a pond or a lake in an urban catchment or in a village, the catchment area is very rarely more than 2 square kilometers. I hope this helps.
Thank you so much, Ranjana. Couple of more slides, and then I'll hand over to Sunil to take the session forward, because today it's going to be a long session. These three variables. these three variables, I think all of you are familiar with by now, because you tried doing. So these three variables, I hope all of you are by now familiar with, at least the ones who tried and mailed me the calculations. So that's the key variables that you have to keep in mind. And also, as Mr. Sunil, he had pointed out, that area is in square meter, rainfall is in millimeter, and runoff coefficient, of course, it varies depending on the surface. If you are calculating in liters, you don't have to do any conversion here. So you can just take this in square meter, this in millimeter, and this as per the table depending on the surface area. And a lot of you had doubt about the 20 millimeter which was there in the table. So this 20 millimeter. So please understand, this is only indicative. You don't have to per se. It's like on a day if it rains 20 millimeters, suppose. So, and if your rooftop area is 200 square meter, and your runoff coefficient for RCC is this, so this is your total runoff. It comes in liters and kiloliters. Is this the total potential? Maybe a little less, which I think Sunil is covering today, wherein you have losses also because of evaporation, spillage, first flush. So those things I think Sunil is covering today. So many of you had doubt on this, so I just thought I'll show this slide. So that's done. This slide, I just wanted for you to understand the difference between visible and invisible water. I think I've shared a lot of notes with all of you on this. So your visible water is basically drinking, cooking, washing. Your invisible is everything. And you look at the big bubble, clothing, fuel, growing food, etc. Everything forms part of your invisible water use. So which is huge, which is 92%. And I just thought I'll get this I had used it for a training program. So if you look at the food portions, and if you look here, like it is 13-20 liters for breakfast here. Wherever you have non-vegetarian, you have the total, I would say, water that is there, virtual water or water footprint is much high. But this is a vegetarian dish that you see with tofu, cashew, broccoli, red pepper, rice. And the water consumption here is just about, what I say, water on my plate is just about 500 liters. So when Sunil told you that it's roughly about 1,500 or 1,600 liters of hidden water that you're consuming every day, you can assume in a meal like this that we have in India, probably that is true. But as I said, in the United States, it's somewhere around 7,000 liters, which is huge. And with that, I think I'll move to the next to today's agenda, and we will be, so let me just stop sharing it here. Yeah. And I'll hand over to Sunil. Sunil, you will be sharing your presentation?
Yeah, I'll do that.
Yeah, thank you, Sunil, once again, and you may please share your presentation.
Okay, good evening, everybody. Am I audible?
Yes, Sunil, we can hear you.
Okay, no glitches, no problem?
No problem, absolutely. We can,
okay.
We can hear you very clearly.
Is the presentation visible now?
Yes, we can see your presentation. Maybe you can put on slideshow. We can see it.
Okay, so good evening, everybody. Welcome back for the second day of the session. I'm going to warn you, this is going to be slightly more than 60 minutes. I will try to cover it in 60 minutes, but given the volume of things I'm supposed to cover today, it may take a little longer. So if anyone wants to have a break or something, just let me know. We will stop for 5-10 minutes. Okay, I try to make it as interesting as possible, but if it gets boring, just let me know. Let us do something else then. Okay, so welcome to the day 2. Okay, so we will commence now. Okay. So what are we going to do today? So we will try to recap of the day 1. Okay, if there are any, I think whatever doubts were there, I think we will try to address. But if anybody has anything to ask or something, please do let me know. Okay, I will try to clarify. But one thing, what I want you to remember from the previous session was the water footprint. So today we are going to concentrate mostly on the 135 part. Okay, we are going to not talk about the hidden water footprint. We're going to talk about the more conspicuous and the water that we use daily. That is the number in which we're going to work with today. Okay, and like I explained in the last session, okay, runoff calculation has broadly only 3 variables. Don't bother about what you get on the internet or on other books. There are many things are attached to that, but basically to get a broad number, these 3 variables are good enough. Okay, try to work with this. And today's session, I'm going to go a little in detail on what exactly a rooftop rainwater harvesting means. As I told you in the last class, it's not the technical term to be used, but since it will become a more colloquial term, rainwater harvesting will stick to that, but seriously, we're not doing any harvesting here. Okay, then we will try to know the components of our RWH setup. Okay, this is not by any means any elaborate thing, it's only going to be indicative. Okay, and to very large extent limited to my little knowledge. Okay, there are far many people doing much bigger work. So what I'm going to do today is mostly limited to what little I know and what little I have worked with. And the system sizing mostly based on what I have come up with. There is no real Indian National Code or any building code which says this is how RWH has to be done. Okay, it's mostly comes from empirical formula and some experience. I'm going to touch very basically about maintenance of the system. As we go on, we will try to discuss what can technically go wrong in these kind of systems. Okay, definitely there will be more questions and I'm open to any kind of discussions because this is no way elaborate, this is no way extensive. Okay, let us try to learn together. And I will try from my experience, whatever it takes to actually a bill of materials. And I want to touch, because since I was told that there are people from resident associations in apartments, where ROI becomes a very important calculation, I'm going to touch upon it. If somebody is interested, we can actually take up a elaborate session on how to actually calculate IRR, or if somebody is interested in more elaborate NPV calculations and so on, we can do it. Okay, but if anybody has any questions in the meantime, madam, please let me know. I will stop because I am on this full screen. I'm not able to see the chat window. Okay, if anybody has any questions, please let me know. Okay. So now again, we will get to the definition. Okay, this is the definition in which we are going to work. The rainwater harvesting, very simply put, is the act of capturing the rainwater. If it falls on your roof, if it falls on your ground area, and either using it for your direct purposes or recharging into the ground. Okay, this is the definition of rainwater harvesting so far as this session is concerned. So now today's session will be exclusively on rooftop rainwater harvesting for direct use. Okay, so we are today not talking about recharge. There's a slight change from the schedule given to you. Next session I will handle the recharge part. Today we will finish completely because I was supposed to cover the economics in the next session, so I will shift it today. So we will today finish both the rainwater harvesting, rooftop rainwater harvesting setup and economics involved in the rainwater harvesting system. Okay, in the next session I will talk exclusively about recharge and the recharge options. So coming to a rooftop rainwater harvesting system, what are the components involved broadly? Okay, so first and foremost and the most important, the catchment. Okay, that is the place where the rain falls. That's our roof. Okay, that is the first component. Second component is the conveyance of the rainwater. Okay, the water which falls from the roof has to be conveyed to your well or sump or a rain barrel or wherever it has to be stored. Okay, so this is the conveyance. Okay, first the water falls in the catchment and then it's conveyed through conduits that we call pipes or gutters. First flush device or a first rain separator. Okay, the plumbing arrangement, okay, where we try to divert the first few minutes of water. Okay, how we do it, I'm walking through the different components. Okay, then a sedimentation tank or a settling tank. Okay, an extension of a first rain separator where the water can be intermittently stored between your filter and your first rain separator, and this water can be used for non-primary purposes. It's basically just a tank. And then a filtration unit where the rainwater gets filtered, and your storage. A storage can be your underground sump or a well or a rain barrel or whatever. These are the broad components of a rainwater harvesting system. You can add on, you can perhaps have a rain chain or maybe have a secondary storage. All those things are additional. I have deliberately not put in the recharge structure because for today's session we are going to concentrate exclusively on storing the rainwater for direct use. Okay. So now the first component, okay, is a catchment. Okay, that is where the water falls. Okay, this forms the major component, the most important component of the rainwater harvesting system. Okay, So a catchment, if you're going to use the water for direct use, must obviously be clean. Okay. Most because this I've found it in a lot of places where I work with, but predominantly in houses and residential complexes, they leave the pets on the roof. So you have to be extremely careful even if you have one. My suggestion is you don't leave the pets on the roof. Okay. And what you do is like arsenic-based chemicals, or there are a lot of chemical-based, mercury-based paints which are used on the roof. You have to strictly avoid that. Okay. And when I tell a lot of people to keep the roof clean. Actually, when they actually do water harvesting, they keep it very clean. By putting soap water, by putting phenyl, by putting Dettol, and sometimes brushing the water into the pipes, which goes and chokes the filter. So you have to be careful even when you're washing it. The washing has to be with a certain precaution. So soaps and detergent should only, as much as possible, use the plain water. Okay, and the roof must be inspected regularly. For example, if there are any dead animals or leaves or something like that. And this is not exactly a part of the catchment maintenance, but you have to check for any stagnation of water, because that can breed mosquitoes. Okay, but eventually, if there is any kind of larva or something, it can get into the water and perhaps get into the rainwater filter. So you must ensure that there is no stagnation of water on the roof. So I will try to see, this is a typical roof setup. Okay. So you can see there are no wires. It's kept clean. Okay, and most people can walk. There's no problem walking, but it's important to keep the roof clean. By what I mean by keeping the roof clean is there are certain things which you have to strictly keep in mind. That is no crackers, no pets, and no smoking on the roof. Okay, if you keep these three things in check, I think it's more or less all right. But keeping the roof clean is very important. Okay, this is one of the catchment areas where I work. There's another catchment area, okay, where it's kept neat. This is an ideal roof, as a matter of fact. It's coated with white paint, a heat seal paint. This also increases the runoff. See, when we talk about the runoff coefficient of 0.8, 0.85, when you coat it with white paint, okay, a heat seal paint, the runoff coefficient actually increases. Say about by 0.05 or 0.06. So for white coated roof, we actually take it as 0.92 as your. So this is one of the roofs where there is a white coating done, which increases the runoff. At the same time, it keeps the roof clean. And white coating also helps you in keeping the roof clean, because the blood doesn't stick on the roof. Okay.
Sunil, one question. I'll just barge in here for a quick question. Is there a way to check that current or existing roof coating does not have arsenic or mercury coating?
I am afraid you don't have, because since it's coated, unless you have the data sheet of the material which you have used. Is there any confusion?
No confusion at all. It's perfect. Just wanted to know that whether there is any problem. How do we ensure? I think one sec. You have to, Sunil. You'll have to unmute yourself. Just unmute yourself. I think you got muted because we were muting others.
Yeah, am I audible now?
Yes, you are. And just requesting you to go a little slow, because some of the participants have requested that little slow when you speak. Thank you.
The question was, is there a way to find out if what is coated on the roof is a food grade material or no? Okay, I'm afraid there is no real way to know what is the material used, because you would have coated some time back. Okay, so if you can get hold of the material, or if you can get hold of the data sheet of the material that you've used on the roof, that can tell you the composition. So tomorrow, and if it is somebody has painted it, there is no way for me to tell by visual inspection whether the roof coating is a food grade quality or no. Okay, it's impossible. Okay, so if you have got anything done, better keep at least a photograph of the box, or keep the data sheet with you so that you can refer to it at any given point of time. But one can say, for example, if you painted now and say after 2-3 years it is almost neutralized, so you can perhaps use it. Okay, but still on a much safer side, I would recommend that you keep the roof off any chemicals, or perhaps use chemicals which are use materials which are chemically inert, which doesn't actually react with water to produce anything which is harmful. Okay, so there are some of the paints. Nippon Paints actually has some kind of a paint exclusively for painting the roof, which is food grade. There's a company in Mumbai called I forgot the name, some polymer SK Formulations. Okay, they actually give this heat seal paint, which is a food grade material. Okay, I'm not advertising for anybody. I'm just giving you some this one. You can use any of these to coat the roof. And most importantly, when you've actually coated the roof, you must make sure that when it rains, for example, it's raining now as I speak. So, for example, if I've coated or painted my roof today morning or yesterday, I must make sure that I don't pick up this water. I should make sure it goes. I'll explain to you how that can be done. But this is about the catchment. Okay, this is what you can see on the screen is actually an ideal catchment. Okay, it is clean, it is white, it is accessible. Okay, this makes a good roof. And since there are some people from the communities, like from apartment communities, there is a tendency there to actually lock up the roof. Okay, so that people don't go there. I don't think it's legally right in the first place, because you can't keep the roof locked because of fire safety norms. On the other hand, also, if you keep it locked, the other problem is nobody will go to inspect it. The other, if you keep it open, people may go and misuse it. But if you keep it locked, also people don't go to inspect it. So you must somehow draw a line. Okay, then you can easily maintain that roof, at the same time it is not misused. Okay, so this is about the catchment. So most important, keep it clean. Catchment clean is water clean. Most of the other things are all actually a myth. Okay, if you actually keep the roof clean, there is nothing more that you need to do other than just keeping the roof clean. Okay, because the only source of contamination for rainwater is your catchment, that is your roof. So if you keep the roof clean, I think the rest of the things just fall in place by itself. Okay, and it starts from here. If you can keep the catchment clean, you can maintain the rest of the systems. If you can't keep the catchment clean, it's quite obvious that you can't maintain the other parts of the system. And I will tell you it right now, this entire thing of rainwater harvesting system, whoever claims whatever, it is definitely not a maintenance-free system. Okay, any kind of filtration you use, any technology you use, it comes with its own maintenance. Okay, so one must be ready to dedicate some time and effort to maintain the system. Okay, so let me proceed now. Okay, this is the ideal, this is the kind of catchment. So this is actually a brief do's and don'ts which I circulate to everybody who actually asks about rainwater harvesting. So this is slide I think will be definitely shared, so I will not go into detail. But if you look into this, most of the things are related to the roof. What you need to do is do not store harmful material on the roof, do not feed birds on the roof, do not store junk material on the roof, keep the roof clean. Everything possible is actually to do with the roof itself. Okay, so all other things actually are secondary. Most important is the catchment. It is true with everything. Okay, if your catchment is, if you've got more forest, the silt will be less in the dams. Okay, if you've got greenery, the silt will be low in your lakes. Okay, if you don't contaminate your drains, that is the catchment, your lakes will be clean. So if you throw plastics in your drain, it will end up in your lake. So catchment management is extremely important. Okay, the only difference between a dam kind of a catchment and your decentralized rainwater harvesting kind of catchment is, there you don't get to see the catchment. For example, I drink water which comes from Kaveri River. The catchment is 300 kilometers away. I must have seen it, maybe I see it only 3 or 4 times in a year. Okay, so I don't even know what happens in the catchment. But in an individual RWH setup, the roof is in my control. So it depends on what. Okay, so keeping the roof clean is extremely important. So I keep stressing this point to everybody who actually talks about rainwater harvesting. Catchment is very important. Okay, so the slides, I think, am I right, madam? I think it's going to be shared, right?
Yes, the slides will be shared. Yes.
Okay, so one can actually have a look at it. Okay, so I'll just move on. So, but as I told you, this is an ideal roof, but it doesn't mean that you can't do anything else on the roof. Okay, so this is also a catchment. Okay, as you can see, there is solar, there is solar thermal, there is a rooftop garden, there is also a biogas plant you can see in this photograph. Okay, so you can actually do a lot of things provided you can maintain. Okay, so you can see here all the parts are actually elevated. Okay, so there is no dampness on the roof, so there is no clogging of water. Okay, all the water just flows down. Of course, in this kind of a catchment, we have an elaborate filtration mechanism as well. but this is also possible. Okay, I am not saying that the roof can't be used for anything else. Okay, this roof can be used for, see, as because it is actually a working model as a house. Okay, I am sitting right below this. Okay, you can also see a workstation there. Sometimes I take the calls from there. Okay. Rooftop can be used for any other purpose as well. Okay, this is the photograph taken today for that matter. Actually, it was raining in the afternoon. I went into this photograph. Okay, so catchment can also be used for a lot of other purposes. Actually, I actively encourage individual houses actually to use the roof more extensively. Just not as you can put solar, you can put.
Sunil, I can see some tiles here on some roof. Now there is a person from Afghanistan who wants to know that suppose they have houses which have got tiled roofs, like mud tile roofs. Then is it possible to do rainwater harvesting there?
Yeah, no problem. No issue. You can do. So, for example, actually a mud roof, right? Even if it's a tile, it's technically a mud roof.
Sunil, your voice is breaking now. Huh?
Can you hear me?
Yes, now we can hear you. Yes.
It's clear.
It is breaking in between now. It was clear all this while, but I think it's breaking slightly in between.
What happened? Okay, any better now?
Yes. Yeah.
Actually, your voice is breaking. I'm not able to get you.
Yeah, so I was just asking that there was a gentleman from Afghanistan. He wants to know that if you have tiled roofs, like mud tiled roof, can you do rainwater harvesting from mud tile?
No problem. You can do.
And the second one was on asbestos sheet.
Yeah.
That if people have house with asbestos sheet roof, can it be used for rainwater harvesting?
It can be used. No problem.
Thank you.
I'll come to different kinds of piping a little later. Okay, there asbestos and everything. But see, it's simple. Catchment can be anything. As long as it's clean, it's good enough. It can be RCC, it can be steel, it can be mud. It doesn't really matter. Okay, so as long as it's clean, I think it's good enough. You're getting me? It's clear? Voice is clear?
Yeah. Yes. Thank you, Sunil. Thank you.
So this is actually the catchment. Okay. You can use it for many other purposes. Even in this catchment where I'm talking, there's a lot of mud runoff which actually happens. Okay, because you can see there's so many pots. To give you a number, there's 147 pots here. Okay, so you can imagine the amount of silt actually which comes out from this. Okay, so of course you have to do some amount of filtration, dispersal, separation, and everything. So you have to factor in all those things when you actually go to design. I am just showing you. I'm not actually telling this is how it has to be. Okay, but it is also possible. But ideally, I would want the roof to be looking like this. Okay, but if you have it like this, there is no problem. Okay, so I don't know if this can play or not, but this is a small video. Okay, so it's actually no problem. In fact, the solar panels makes even better catchment. Actually, I have gutters on this panels. If you can see here, okay, there's a gutters here. Okay, you can use. Hello.
Can you please mute your mic? Sunil, I am trying.
Hello?
Yeah, perfect.
No, I think every time you're trying to mute, you're muting me as well.
That's the problem with Teams, that you can't, it mutes everyone. Huh?
Okay, so I was talking about, the solar panels actually makes a great catchment because it's glass, okay, and its runoff coefficient is one of the highest, okay, and you can see in this photograph, I've got gutters here, okay. So all the water which falls on the rooftop doesn't fall anywhere else. All the water which falls on solar panels doesn't fall anywhere else. It just falls on the gutter and actually goes into my rainwater harvesting system. Okay. So you can actually, somebody asked me right now, can you use asbestos sheet? Can you use banding tile? It is similar to what I've done here. Okay. You can just install a gutter, okay, to collect the water from there. Okay. So this is the video I think you saw. I think we can share. So Next part of the system is the conveyance. Okay, the water which falls on the rooftop, how does it get into the next set of arrangement? Okay, so you can use either rain chain or you can use the CPVC pipe, you can use PVC pipe, metal pipe, stainless pipe, whatever it is. Okay, but for a decentralized rainwater harvesting setup, I'm going to just explain how this can be done. Okay, I recommend to use PVC as much as possible for simple reason that the friction is very less. Point number one. Point number two, doesn't get corroded and it's very simple to actually fix. Okay, there is no threading, no welding, nothing. Okay, you can just use a normal PVC glue to actually fix this. Okay, and I recommend to actually put a little bit of detail into the design of the piping system. It is not as simple as just buy whatever is available in the store. Okay, it's always good to use a pressure rated pipes which has got pressure rating, because there are a lot of unbranded, unrated pipes available. Try not to use as much as possible. Okay, so those who have got some academic bent of mind can refer to this code. Okay, this is the code of practice for plumbing, so you can use these SWI pipes, conform into this code. Okay, then automatically come in pressure rated pipes. Okay, so pressure ratings are actually available. If you go to the website or you go to Harvester and find out, there are many gauges. They'll ask you what gauge of pipe you want. So you have got 0.4 MPa, 0.6 MPa, 0.8 MPa, those kind of things. So essentially it means that the pressure on the walls of the pipe is equivalent to 4 kg per centimeter square. Okay. So for most residential and semi-commercial use, 4 and 6 are good enough. Only for like really large catchments and large volume of water flow, you need to go for a higher pressure rating. Okay. So you can see this is the piping. Okay. You can actually look at the this one. This is a vertical, horizontally movement, like the moment the water falls on the roof till it gets to the next step. Okay, this is the piping arrangement. Okay, this is an old house. Actually, you can see I have made sure that the pipe doesn't touch the wall. Okay, so no clamping or anything on the wall. So there's a cantilever kind of an arrangement. Okay, so you can see that you have to add some detail. Okay, those who actually come from engineering background, they know you just can't have the pipe just as it is. You have to design the air vent. Okay. For pressure to get released. So it happens even for filtration you have to put air vent, for conveyance you have to put air vent, for underground piping you have to put a lot of air vents, you have to extend the careful about, otherwise it's going to get airlocked. Okay, this is a matter of detail. When it gets to engineering, they can design this. Okay, so how do you size? Like what diameter of pipes are required when you are doing this kind of a catchment? Okay. National Building Code gives you a lot of data on how to actually do it, but easy way to calculate is you need to have a 5 centimeter cross section for every square meter of the catchment. Okay, this is easily I have reduced it using all this thing, so you can just use it. Take this formula. It is slightly over designed, but it can work very well. Or if it's a very critical structure, for example, if you're doing in a hospital, okay, where you don't want any maintenance, you don't want any kind of problem at any given point of time, you can take 6 or 8 or 10. It depends on the sensitivity. Okay, where actually you're doing. Okay, suppose if somebody wants to do it in ISO lab, they don't want to even have any kind of problem. The factor of safety is 3 or 4. Okay, so this is the simple way: 5 square centimeter per every square meter of the roof area. Okay, so I just give an illustration of how it can be done. For example, take a roof area of 200 square meter. Okay, so what kind of cross section area of the pipe you require? Okay, it is simply 200 into 5, that is 1000 square centimeter. Okay, generally what happens if you look at any roof, the roof will have multiple slopes. Okay, what we call as the ridge lines. Okay, so now this 200 square meter will not flow in a single pipe in most cases. Generally, it will be 2, 3, or 4. For ease of understanding, I have just split between 4 lines. So each will be 50 square meter. So this total catchment is 200 square meter, out of which 50 square meter is connected to one pipe, and that's how it is split. So there are essentially 4 downtake pipes. Okay. So how do you size this system? Okay. So now, if it is 50 square meter is the catchment, you need a total cross section for that particular quadrant as 50 into 5, that is 250 square centimeter. Okay. Now, what is 250 square centimeter? how do you convert that into diameter of the pipe? Generally, pipes are available in diameters. Okay, if you go to a hardware and ask, pipe, give me a pipe, you say what diameter you want. Okay, so now if I have to convert this cross-sectional area into diameter, so pi d square by 4 is equal to 250. Okay, the cross-sectional area of a circle is pi d square by 4. I'm sorry I could not write it down here. Okay, so I think everybody knows the area of a circle is pi d square by 4. So pi d square by 4 is 250. So there's only a single variable, that's the d. So d is equal to 250 into 4 by pi, square root of that is 178 mm. So you need a pipe of 178 mm for this kind of a catchment. Most of the practical engineers will actually quickly make out this is an over design. Okay, so you don't need so much, but for ease of understanding, again for 5 you can take 4 or even 3.5 works pretty well. Okay, so but 175 mm pipes are not available. Okay, so you get in 90, 75, 110, 160, 210 and so on. So what you can do to match is 178. So you can use the nearest diameter, that is 90 mm, use 2 of them. Okay, so that can easily carry this kind of a water at 4 kg centimeter square pressure. Okay, I hope I am clear. If any doubts come, I'll address it later. Or if there is anybody asking me doubts, you can let me know. Okay, so this is how you actually size the pipe. But when it comes to gutter, okay, gutter is actually little this one, so you have to size it 10 to 15% higher in terms of cross-sectional area compared to a pipe. Okay, density for the water to actually spill out from the gutter. Okay, so you take about 10 to 15%. Okay, that is good enough. So where do you use gutter? Where you got sloping roof, where you have got asbestos sheet, or you've got mangrove tile, or in my case I have a solar panel. Okay, so you fix the gutter to carry this water. Okay, so how do you size the gutter? Same principles, but take about 15% higher. So that will hold good for the gutter. Okay, so I just tried to add some academic stuff here. If any students who are listening to this, okay. So what I essentially use here is there are 2 principles in hydraulics: the velocity of water and the head of water. Okay, so velocity and head. So head is the height from a datum at which the water stays, and the velocity. Okay, so there are actually equivalents. If you look at things, there are many equivalents in other subjects. So if there are any students who are really interested, they can actually relate head of water and velocity of water to voltage and current, and perhaps come up with a relationship. It is just giving a food for thought, you know. Because instead of just giving some boring lecture, I think I just added this. If the any students who are interested can actually go into it. It's not any like that. If you're interested, you can go into the detail, okay, and work with that. Okay. So with this, I will proceed further. Any questions here?
Yes, there are a few questions. One question is on whether the, I think the height of the pipe or something, yeah. Would height of the roof building have any implication on size of the pipe? The other was also on the slope of the roof. What is the slope required for the roof? Huh?
Okay, see, height, see, so far as the cross section is concerned, yes, you can, it has some kind of a bearing, but generally the higher, the more head. So the pressure will be more. So instead of a 4 gauge pressure, you may have to go in for a higher gauge of pipe. Okay, so maybe 6 or 8 gauge, because as the height increases, the head of water also increases. Actually, there is one relationship. So the height of discharge versus the surface area. If you can refer to the National Building Code, okay, you will get more detail. Actually, if I go into it, it will take a very long time. Okay, it's an extremely technical subject. Okay, so it will take minimum 2-3 hours just to arrive at the calculation. So I'm not going to go into lot of detail on this one, on the cross section and the gauge of pipes. But I've just given you a normal residential apartment, for example, everything which is less than about 5,000 square meters, this formula can hold good, irrespective of the height of this thing. So coming to the slope, see, the slope generally is not in your hands. Okay, so you have to work with what is slope given to you. Generally, an architect designs what is the slope depending on the aesthetics of this thing. It is the same thing to do with the height. So Greater the gradient, greater is the height. Okay, so the logic remains the same. If the height of the building is roughly equivalent to the slope of the roof. Okay, so the more the gradient, more is the velocity. So you may have to size the stuff accordingly. But generally speaking, any practicing engineer will actually can make out by visual inspection, what kind of pipe is required. You don't need to go into any of these actually calculations. Okay, for example, when you actually build a house, nobody actually does these calculations. You just use a 3-inch pipe or a 4-inch pipe. Okay, because by experience, people would know that. But if one really wants to go into detail, National Building Code has got very elaborate calculations on how to do it, because there are other variables also, right? The number of bends required. Okay, so more number of bends, more friction. Okay, for the friction, how do you account for it? For longer the length, there will be problem of surging of water. So you may have to take that into account. So I'm not going to get into all those very technical details because that will become a presentation by itself. So this is only a broad way to do. Like as I know, 5,000 square meters and below, this can work very well. Okay, any more questions, ma'am?
No, I think we are good to go at this point in time.
Okay.
At such time that people ask more, huh?
Okay. So I will just run through some pictures. So you can see here, this is an underground work where we have used an 8-gauge special pipe. But since there is going to be lorry movement on that, actually you can see there's an MS covering on this pipe. Okay. So in this case, where the pressure was actually even sufficient, there's extra pressure, not only the internal pressure from the pipe, from the water, there's going to be load on the pipes. So there's extra reinforcement given. Okay, so you can see there's an MS pipe. Inside it there's a PVC pipe. Okay, so this kind of detailing one has to work out depending on the site conditions. So what formula I gave is not like a universal formula. So depending on the site conditions, you may have to change the variables there. You can see here, you can see there's an MS pipe. Inside that there's a PVC pipe. This is asbestos sheet guttering. Okay, so actually you have to be a little careful in detailing of the gutter, because if the gutters are not fixed properly, because of surface tension of water, all the water can actually just go out. Okay, because if you can observe, when the water falls from the sloping surface, it sticks to the walls. Okay, so it actually takes a turn, a couple of inches, and then falls down. So if you don't detail the gutter properly, you are going to lose a lot of water. Okay, because of surface tension. Okay, so this detail I am not going to tell you how to fix, how to draw this and all, because it will take a lot of time. But you have to give some cognizance to the detailing. Okay, like how to fix the gutter. Okay, it will generally come from practice. Otherwise, you have to like push the gutter a little inside, so that even when the water sticks to the walls of the asbestos sheet or the wall, the water ends up falling inside the gutter and does not leave outside. Okay, there is a question on asbestos sheet. You can see it's being done. Okay, this is a typical arrangement in a residential apartment. Okay, this is how this net worked. This is gutter coming into a pipe, and further it's going somewhere else. So this gutter and pipe together. So here you can see there is no support. Okay, so we have made a MS connection so that the pipes are supported properly. If you can put some cognizance to the details, the pipes actually starts from 4 inches, 6 inches, and then goes to 4 inches. Because vertically you need a lesser cross section. Horizontally you require more cross section, because vertically there is greater slope available. So because of surface tension, the water doesn't actually never falls in full. If you take the cross section of the pipe, it may be half or 3/4, most cases less than half. So you reduce the cross section to predominantly to save the cost. Okay, this is another arrangement, because there is no support. There is no support area. We have made a bridge kind of an arrangement to transport the water. So again, residential community where we have used this thing. But I am sorry, there's no point or anything I can make out. But you can see one Y joint there. Okay, generally that's again a matter of detail. Okay, because the water comes from a large head, say 4, 5, 6 floors, it comes with a lot of pressure and velocity. Okay, so generally if you put a T joint there is a direct impact. So there is a good chance that the pipe lateral. So you have to give some kind of a free movement using a hanging clamp. At the same time, there T joint. T joint builds up
इसके लैपटॉप में ना ऊपर एक पावर का बटन खराब है यार, वो जरा तो उसका वैसे
Am I
Can you
audible?
please have yeah, fine. Thank you.
Yeah. So try to avoid T joints as much as possible, because T joint builds up a lot of stress. Okay, there's a lot of propensity at the joint to actually fail. So try to use Y joint, because the water gets in at an angle at 45 degrees instead of getting it at 90 degrees. So if the water is at 90 degrees, there will be a lot of stress and a lot of friction. So the pipe may break at that joint. So if you use a Y joint, that is taken care by a large extent. Okay. So this kind of arrangement is possible. In very, very rare cases, that Y will not be possible, where there is no other option. You have to put a T and somehow the movement using a. Okay, so if somebody is interested, we can go in detail about this, because I don't want to spend more time on how much stress builds up, what will be the friction force and all. It gets into a lot of academic discussions, which is actually of no consequence. Okay, so this is another arrangement. Okay, so piping on a wall. Okay, this is a vertical. This one is done in a government school. Okay, so this is about conveyance. That's how the water is conveyed from the catchment to the next point. Okay, then now we will go into the filtration aspects of it. Okay, filtration, three important components. Okay, the first time separator, the settling tank, and the actual filtration itself. Okay, so the first part is the catchment, from there the water flows, where the water falls. Then the conveyance, that is where the water flows. Okay. And the third thing is the filtration, that's where the water gets filtered. So flow, where the water falls, flows and filters. These are the three important steps: where the water falls, how the water flows, and then where the water gets filtered. Okay, so this is a third step in the rainwater harvesting scheme. Okay, so we have had the water coming on the roof, then we have the water getting through the conduits and getting into the filtration mechanism, and then it goes to the further use. Okay, the filtration, if you ask me, has to go through three stages. Okay, in literature, if you go on the internet, you can find a lot of material on how to filter this water. Okay, you can all go to the on YouTube, but I will try to tell what I have been practicing. This is not the way, or this is not the only way, or this may not be the correct way. This is what I have been practicing and been working very well for last so many years. Okay, so first step in filtration is what we call a first strain separation, or a FRS. So the first strain separation is used to segregate the first few minutes of water. Generally, the maximum contamination comes from the first few minutes of water. The urban dust, the leaves, whatever is the visual sediments comes in the few minutes of water. So after the first step of keeping the catchment clean, this is the second most important thing, to actually flush out the first few minutes of water. Okay, it's called FRS, or first strain separator. How it is done? Okay, generally it is just a plumbing arrangement. Okay, so you arrest the water at a lowest point through a valve or a cap. Okay, and let the water build up in the column. Okay, so when the water builds up in the column, okay, the water column essentially acts as a first strain separator. So the water standing in the pipe is essentially wasted water. Okay, that will carry the maximum dust. When you open the valve, it will go out into the wherever it has to go. Okay, so this is the first strain separation. Okay, and the other thing it does is actually it also acts as a bypass valve. For example, for some reason, if you don't want the water, for example, you accidentally burst some crackers on the roof, or you have done some party on the roof, or there is some Diwali and people have done party or burst crackers, and not by intention, accidentally it has happened. So way to bypass that. You don't want the water to get into the further filtration or get into the sump. You can just open, and the water gets into the drain, or just goes out. Okay, this is called a first strain separation. Okay, this is the detail. Okay, you can see in this picture the water is coming from the rooftop. Okay, and there's a Y joint. Again, the Y joint is given. If you give a T joint for smaller rains, actually water will start flowing laterally because of surface tension. It doesn't come down at all. So you have to make sure that it's a Y joint. So the water builds up in this water in this pipe, and subsequently when the water fills up, till the Y joint. When it overflows, it goes further. So the water which is stored in that water column is the first initial couple of minutes, 1 minute of rain, which you can open the valve and drain it out. So this is how a typical first rain separation works. So if you can see, this is actually one which is done in the. You can just see the small video. So you can see the valve here. So when you open it, the water just when you close, the water and then goes into the filter.
Gaurav, please mute your mic.
Am I audible?
Yeah, you are. Huh?
Should I repeat this?
And maybe yes.
Yes, please.
And you can take a question also which says the weight on the roof increases as we store water for a long time and the building gets old after a year, and it may cause problem to the building. So is there an impact on the building? So you may have to explain that we are not storing this on the roof. Huh?
Yeah, let me answer the question, madam. So nobody is storing the water on the roof.
Yes.
Which falls on the roof just gets into the filter or just goes into the sump. Essentially, you're not using the roof as a storage. Okay, so nothing really gets stored on the roof. Other than keeping the roof clean, there's no other activity on the roof. Okay, so roof can be made of anything else to be done on the roof just to keep it clean, and no build up on the roof because water falls and goes into the conduits. You're not storing anywhere. Coming back to first rain separation, this is how a typical first rain separation is. So you can see the water column with the valve fitted. So when the valve is closed, the water is built up in this water in this pipe. That is essentially wasted every time you actually open that valve, and the water keeps going out. Okay, it doesn't get into the filter. So when you don't want to use the water, you can keep the valve open. When you keep the valve closed, the water which is there in this column is essentially the first minute of water, which actually can be thrown out. You have to actually open the heavy rain to throw that water out. So you can see the.
I think, yeah, there's a disruption in your voice here slightly.
No, I stopped.
Okay, right.
So you see, when you open the valve, so the water goes out. So every time it rains, after the rain stops, you have to manually open it, or you can have an automatic arrangement as well. But this is the valve which is used to throw out the water. When you close it, the water builds up in this water column, okay, and then the overflow gets into the filter. So the first minute of water actually comes in this pipe, and it essentially gets. And see, this is the Y joint to take care of filtration forces. So there is no T joint. So since it's a Y, the water essentially has to flow. Okay. So in that video, you saw a valve. Okay. So the valve actually makes a very important detail in the entire system. So in the rainwater harvesting setup, the maximum pressure is actually there on the valve because that's the lowest point in the entire setup. So all the water essentially comes there. So generally, I've seen people using very substandard material when it comes to valve. Okay, because valves are actually pretty expensive components, and people try to cut costs here because they're more interested in aesthetics. And what happens is they use a very substandard valve. Okay, because like electrical items, plumbing items comes in very cheap and very expensive, both ranges. Okay, so why I'm stressing this detail is it's very important to actually put a pressure-rated valve for first rain separation. Okay, you can see here this is a 10 kg force. Even though the pipes are 4 kg force, the valve uses a 10 kg pressure-rated valves. Okay, so this will help retain, and it's definitely expensive, but it's worth the investment. Okay, so make sure that if you're a practicing engineer, that where the surges are maximum, where the pressure is maximum, use the best quality material there. The longevity of the system actually increases. Okay, I just wanted to show this picture so that to dive on the point of a valve. Okay, so there is another arrangement. Typically, how it works: so the water comes from the rooftop. This is the first rain separator. there is a Y joint, and then there is a filter. Okay. Now, one more.
Sunil, can you explain the filter a little more, because there is a question on clogging of pipes. Huh? So how do you clean when the pipe?
I'll come to you later.
Okay, thank you.
So the next setup after first time separation is sedimentation tank or settling tank. Okay, it's an extension of a first time separation. Generally, what even for in a residential community or in an individual house, you may not get that kind of a volume for first time separation. Okay, the rule of thumb is you may have to at least flush out 0.5 liters to 1 liter per square meter of the roof area. So since we don't get this kind of a volume, we extend it a little bit by using a settling tank or sedimentation tank. Okay, tank is just an extension of a first time separator. Okay, it's a tank or a rain barrel which is used to store the water. It's an unfiltered water, and this water can be used only for secondary purposes. Since it directly falls from the roof, it can be used for secondary purposes. Okay, so this is how a settling tank looks like. Okay, from the first time separator, the water flows into the settling tank. Okay, so this settling tank holds little water, and the water stored in this tank can be used for non-potable purpose, like washing or washing the floor or something like that. Not for essentially potable purpose like drinking and cooking. So this is a settling tank installed at a certain height. This is again a settling tank. You can see there is a valve here, first time separator. Then there is this water. Essentially, the first minute of water is stored here. Then the water overflows into this settling tank, also called a rain barrel. And you can see a tap here. This water will be used for non-potable use. And you can see there is an air vent provided so that there is no airlock anywhere. And the overflow from this rain barrel will go into the filtration. Okay. So this is an extension of the first time separator. But this water can be used. The water in the first time separator is essentially wasted water. The water here can be actually used. Okay, but for secondary purposes. So it is another.
Sunil, two questions. One is, if we are storing the water for greenfield watering only, do we need to go with FRS? And the second one is, why we can't use T rather than Y junction for FRS?
Okay, so the first question I will address later because I am made to come to that. Okay, so I address the second question. I think I did mention why you have to use.
Yes. Yeah.
If you use a T junction, what happens is if you have generally when you are, because you are putting this valve on a vertical section, so water is flowing vertically down. Okay, so when you actually see the cross section of the pipe and the water is flowing, the water actually will be sticking to the walls of the pipe. Okay, the reason being surface tension, because surface tension property of water, the water will be sticking to the walls of the pipe. So if you have a T joint, what can happen in a small drain is, because of surface tension, a little bit of water can get into the T and go further laterally than flowing down. Okay, that is why we use a Y joint. Okay, it's actually nothing really can go wrong if you use a T joint, but it's better to use a Y joint so far as a first time separator is concerned, because for even a small drizzle, you will make sure that the water just comes down and doesn't get into the further filtration. But in the plumbing arrangement which I showed you, I think sometime back, here it's very important to mandatorily use Y joint, because if you use a T joint, the water hits at 90 degrees. When the water hits straight, the pressure is much more. Okay, and the pipe can move laterally and can break. So if you do this kind of an arrangement, okay, the water hits at an angle. Okay, so the friction will be much lesser and the pipe has lower chances of breaking. Okay. On the piping arrangement, Y is mandatory, but for the first time separator, you can use T instead of Y, but using Y is definitely better. Okay, and the smaller drains, there is a chance that if you use a T joint, the water can get into the T joint instead of flowing down. Okay, I hope I answered this question, and I'll come to the greenfield thing a little later.
Thank you. Thanks.
So the sedimentation tank is, as I told, is an extension of the filter. Okay, it is just a storage. You can see this is our sedimentation tank. This is the water from the rooftop gets into sediment. The black color thing is the sedimentation tank. Okay, and this one is the overflow gets into the filter. the filter water further goes up. So this is a sedimentation tank. Even if you don't use it, it's not a big problem, but it is recommended that you use it because there's a lot of silt. Sometimes the roof doesn't get maintained very well. You have a lot of silt coming from the roof. Okay, that can all get trapped in the sedimentation tank. Okay, as a good practice, it's better to use this. And the water is not wasted, mind you, it is still harvested. It's just that you're not using it for primary purpose. You're just using it for secondary purpose. Okay, these are some examples of a first rain separator and sedimentation tank and filter. It's all done in some communities. And now I come to the thing of filtration. Okay, it's actually it's kind of it's talked a lot. People talk a lot about filtration. You have to do like this, you have to do like that. But I'll put a few questions before actually answering them. Okay.
Yeah. Also, one question on first rain flush is that if somebody forgets, then what happens? And what is the right time to open that? Open the valve.
Okay. Well, if somebody forgets to open the first rain separator, they are in soup. Okay. Because the next rain, when the water comes, that water will straight go into settling tank. It doesn't get flushed out. Okay. So generally, what you can do is you can keep the valve a little loose. If you think that you may not be able to maintain it, or you may forget it, you can just give a 5-degree turn to the valve, so that the water keeps leaking down. Okay, and it goes off. You don't have to actually manually open it. You also have these days something called a centrifugal filter, which eliminates this entire requirement of opening and closing. But the problem is there's nothing in the filter. It's just a mesh. Essentially, you use the centrifugal force of the water to push the water, and the heavy material is going to fall down. But any kind of clogging, you will have the entire water going down. I'll come to that later. But coming to this question of what happens if you just forget it, it will start stinking. So the water will start stinking in about few days. At that time, you will definitely go and open because you can't bear the smell. What was the second question? Clear?
Yes. The first, it was what is the exact time to open the valve to flush the water for the first time?
See, but generally, every rain, you open the valve and push the water out. Whatever is stored in that pipe, you throw it out. Or you can, what I generally tell people is, because they come to the same question, what if I forget? So I tell everybody, as a matter of practice, if it rains or no, monsoon or no monsoon, every week open and close once. It takes about 10 seconds. Okay? Open and close, so that even if there's the water, it will go. If there's no water, no harm, it will get lubricated. Okay? So ideally, after every rain, if you think that you may forget it, like once a week, just open and close. Okay? So that it becomes a practice. Okay? And then was there one more question? Hello? Can you hear me? Okay.
Sorry, my mic was muted. Can you hear me now?
Yeah, I can hear you, ma'am.
So it says that can we avoid manual intervention here? How can we make it completely hands-free?
You can use a solenoid-based valve if you want. Okay, you can put a PLC there and control that. Okay, that is possible. You can do automatic valves are available. You can use them. You can also use a centrifugal filter instead of all this filtration. You can use it's available off the counter. You can just go buy that filter which comes with the flush out valve, which actually happens automatically. Personally, I don't recommend. Okay, but it is still a lot of people prefer that and using it. But for me, it doesn't really kind of catchment I work with. It does not work very well, and I don't recommend it also. But if you automatic valve, they are available. You can put solenoid valves and put a PLC to control that. As a matter of fact, you can set it like every day morning 6 o'clock it opens and closes for about 30 seconds. That's kind of possible. You can do that. But personally speaking, I would say that if somebody does it, it's better, because this entire rainwater harvesting system is actually not a maintenance-based system. You need to relate to that. Okay, you can't. It's not like fit and fix. It's not like going to the store and buying an iPhone. It doesn't work that way. So some amount of relationship to the system is required. So it is better that one takes a look at it, does it manually. Okay, it doesn't hardly takes 10 seconds. Okay, so if it does it, it's good, so that you relate to the system. You make sure it's working well. Okay, that way the longevity is increased, and you also take care of system very much better, because when you are handling it, when you're working with it, okay, you actually take your system better. For example, even the rooftop garden, I've seen a lot of people actually putting automatic irrigation systems. They all work well starting. After some time, people lose interest, and it keeps watering, and I think the system dies down by itself. Okay, so it's better to relate to a system. When you relate to a system, it actually works much better. But to cut the long story short, you get automatic valves which you can actually install. Okay, can I move on?
Yeah, thank you. We can move on. Yeah, thank you.
Okay. Well, I think I'm seriously short of time. I'll try to finish this. Okay. Next is the filtration. Okay. So now I come to the important question: why it is required? Is it required at all in the first place? Okay. Now, as we all know, rain is supposed to be the purest form of water. So, but still, do we need to filter it? Okay. Given that we have already flushed out the initial few minutes of water, do we still need a filter is the question. Okay. To actually answer this, I also don't know. Okay. So I will try to tell you what little I know, but very frankly, I also don't know the answer to all these questions. Okay. Now, to actually look at this, we have to understand why they are also using the filter at home. We may be using the Hemamani filter, whatever, Kent or something, and then RO. So many other brands. Okay. So why do we actually see RO is a different concept altogether. If water is hard, you need an RO. But if it's salt water, you don't need actually an RO. But why do we actually have a filter at home? Because there is some amount of scare, and there's some amount of psychological angle involved with that. So we use a filter at home, and it's good to use the filter. But why do we need filter for rainwater? That's the question. Okay. So what does the domestic filter do? I think I answered this question. Okay. Now what we need the filter for? To filter what? To filter the physical matter, chemical matter, or biological matter, or all the things. Okay, I will try to address these questions. Okay, and then we'll see what we arrive at. Okay. Now, what should actually the filter do? Okay, you already kept the roof clean. You already flushed out the first few minutes of water. You've also taken the subsequent water in the settling tank, but still installing a filter. So, what does this filter do? So if there is any physical contamination like twigs or leaves or dust, it is supposed to filter that. Okay. And sometimes not in southern India, in northern India, I've seen some people complain there's some smell in the rainwater. Okay, you have to take care of that. Okay. And most importantly, like most of the people I meet, there is a psychological need. Okay, even the university professors, they actually ask for it. I need a filter. I can't trust the rainwater. Because as I told you in the previous session, the only possible source of water is the rainwater. There is no other source of water in the world. So if you don't trust the rainwater, what is water will you trust? That's the question. Okay. But this overwhelming response I get is more of a psychological need than the actual need. Okay. Why you need this? Because when you see the stream of water flowing, you go and drink. You don't take an hour there, you don't filter nothing. You just drink that water, right? So we have that confidence, but we don't have the confidence for the water which falls on your roof. Why? It's more of a psychological question if you actually ask me. Okay. Now, I will not get into all this COD BOD talk at this point of time because it is totally irrelevant so far as the rainwater is concerned. Okay. Because I just put this point here because there's a lot of technical discussion, lot of questions asked about COD BOD when it comes to rainwater. It is totally irrelevant. We don't need to talk about, we don't even need to mention these terms, because it doesn't relate to rainwater at all. So if somebody is telling you, we need the filter to take care of COD or BOD, no. The rainwater doesn't have any of this, so we really don't have to bother. Unless you're going to have some kind of mixture out there, it doesn't really come into picture. So COD, BOD is irrelevant as the rainwater is concerned. Okay. So now, given that for a time being, we'll assume that we require a filter. Okay. But for the time being, we assume that we need a filter. Okay. So what filter must be what? Most important, it should be easy to install. It must be easy to clean. Okay. It should be easy to access. It cannot be underground. It can't be some corner. It can't be somewhere where your pets go and rest. No, it should be easy to access. okay, easy to inspect, decent to look at, filter effectively. What it filters will come that later. Okay. The last one actually for me is the most important. Have a provision for testing the filtered water. Okay. So now given that we need a filter. Okay. So what kind of filters are available in the market? Membrane filters. You all know there are a lot of membrane kind of filters are available. Electrical systems like Germany, you can see a lot of systems where they use electrical power to actually disinfect the water and subsequently discharge into the sump. Now, graded metal and charcoal filter, this is the most widely used and perhaps the most ancient. And the cartridge filter, this is the most recent one and more off-the-shelf kind of a solution. Okay. Now, the filter, if at all we need to install one, predominantly for 50% for psychological needs, other 50% is for generally you still have some amount of dust in spite of the first-time separation. Particularly in my own house, more than the dust, I have got some soil, I have got a lot of leaves coming in. So I need to trap this. Plus, there is some amount of gas or some dissolved gas in the water which I need to absorb. So I use some material like charcoal or activated carbon to take care of that, and some pores in those carbon which can actually trap my dust. Okay. So the one thing I'm going to talk to you today is a which I call it as a modified rapid sand filter because it's slightly modified from the original design of a rapid sand filter. Okay, which is essentially a very old concept. I personally don't believe in the cartridge filter, so I'm not going to talk about it. But today I'm going to talk mostly about the modified sand filter and its design. And mind you, I never told you what should be the volume of the first-time separator and the settling time. And nobody asked it also, so I'm going to stress upon the filter and how to size those kind of system. So coming to this modified rapid sand filter, it is like most practitioners will know what the rapid sand filter is, but it is just a small modification from a conventional kind of a sand filter. So it, in multiple stages, can be underground or overground. Okay. Actually, what it contains, this is the most important. Okay. So I use these. This is not even this is what I have been using. So I use these filter media to filter the water. Not in the same different sequences. Sometimes I use sand, most times I don't. Then I use silex, different gradings, 20 mm, 40 mm, and 10 mm. Then I use activated carbon, technical name IV900. Okay. Then I use cinder. All of these are filter material. Essentially, all of them have got pores and certain chemical properties which can filter the water. And provision can be given, okay, to clean the filter because filter also gets clogged. So you need to keep cleaning it once in a way. Okay. So,
yeah, Sunil, just a couple of quick questions. There was a question on BOD and COD. So I'll request you to just throw a little light on that. And then pollution, for instance, places like Delhi, which is mostly, the air is polluted. So what do you have to say about the water quality that we are harvesting from there, and how do we really filter that?
COD is irrelevant, as I told you, for a race. Because there is no chemical oxygen demand, there is no biological oxygen. There is no bacteria as BOD.
Yeah,
okay.
Thank you.
So there is, I think, so far as rainwater is concerned, let us not talk about COD, BOD. But if it's water in general, COD, BOD, maybe we can have another session. Because BOD will take a lot of time.
Absolutely.
What we need to do, I will start with that.
And the pollution, Sunil?
Pollution, actually, as a matter of fact, we haven't really seen kind of an acid rain getting into the rainwater filter and causing any trouble. But pollution as such, the dissolved gases in the air can get which can get into the water. So the best way to filter this is to carbon filter. There is definitely going to be some amount of dust and some amount of gases, okay, which you need to take care of, particularly areas like Delhi, northern Karnataka, where you've got power plants, you have this problem. Okay, so essentially what we do is we pass it through a large bed of activated carbon. The same thing you might be using in your normal, you have filters, commercially available ones, which will have the cartridge made up of activated carbon. Here you put, essentially you put rock, activated carbon in a large bed and make the water flow through that. Okay, so we have tested a lot of samples. Okay, input to output, there's a significant difference. Okay, I'll share those details with you a little later. But yes, it's like Delhi, there will be atmospheric pollution where you need a kind of a filter. Best thing is to use activated carbon. Okay.
Thank you. And the same filter would be used for the mud tiles roof also?
Yeah, in my opinion, you can use the same filter. So most important where there is sandy conditions, okay, where there is a lot of wind, is that to use a good settling tank. The settling tank must be equal to at least 1 liter per square meter. So that's what I mean is, if you have a roof area of 200 square meter, have a settling tank of 200 liters. So that every time it rains, the 200 liters of water is not getting into the filter. It just gets in the settling tank and just either used for secondary purposes or thrown out. Silt gets trapped there. Okay. For example, at a place where, Chennai, where sometimes you can have a lot of wind. Okay. So you have a lot of dust coming in. Okay. So I'm sorry, not in Chennai, maybe in Delhi. So sometimes you get these, I don't know what you call, you get this lot of, you get this wind, no? Dust. Okay. So then just settle on your roof. Can you hear me?
One second. I couldn't get you. Sunil, you were asking.
Yeah. Should I start from the settling tank?
Yes, please.
So essentially, you have to have a settling tank where there are dusty conditions. Okay. For example, your house or your factory is next to a graphite factory, or a factory where there's a lot of soot coming out. Okay. There you need to have a good settling tank. Okay. So a rule of thumb is 1 liter per square meter as the volume of a settling tank. But if you are coming from a very dusty area or near any factory area where there is a lot of soot coming out, you can increase that volume. There's no rule like this has to be volume. Depending on your judgment, depending on the kind of contamination you see, you can change the size of the settling tank. Okay. For normal urban India, 1 liter per square meter is good enough. But depending on the sensitivity, for example, if the water is stored for hospital purposes, for example, if the water is used for some treatment or some jeans washing, where the quality is important, you have to go for a slightly higher settling tank. Okay. Then the filtration, large amount of cinder and activated carbon will take care of this dust. Okay. So can I move on?
Yes, Sunil.
So this is the modified sand filter. Okay, as I told you, it can be a single chamber or double chamber. It can be over underground. These are the available materials for filtration. You can give a provision for backwash if required. Okay, so this is a typical design of a overground single chamber rainwater filter. So the water gets in from the settling tank through this pipe. This is called a splasher stone. So when the water hits the stone, it essentially gets spread. Because you don't want the water to come in one direction, you want it to spread in the other dimension also. So water filters through all this media. I forgot to add activated carbon here. You can put activated carbon here. Then the water from the bottom can get into the sump, which you can use for primary purposes. So this is one design. Okay. So this is how it's going to look. So this is the settling tank. This is the sand filter. The overflow, the filtered water goes from here to the sump. Okay, this is a typical connection. This is the second mechanism. Okay, this is what we do most of the time. So what happens is that from the settling tank, the water comes here. Again, the splasher stone. When the water hits here, it gets spread. Then we've got 20 mm aggregates, or rather the silex, not aggregates. Then 40 mm. Then it goes down like this. It's called upflow filter. This is the direction in which the water flows. So then it goes into a layer of cinder. Then it goes into a layer of activated carbon. Then again a layer of silex. Then the filtered water gets into the sump. From here it goes into the sump. This water is technically fit for drinking. Okay. But mind you, catchment should be clean. First line separator, settling tank, and then the filter. Okay. So this is how it's going to look. This is what the 2 chambers filter is going to look. It comes from here. Filters goes down, comes from the bottom, comes up and overflows from here. This is a typical design. of a 2-chamber filter. Okay, this is a closer look at the same thing. Okay, this is how it's going to look. From the top it comes here, chamber 1, chamber 2, then it gets into the sump. So this is a different arrangement, settling tank, filter. So this is what the finished filter looks like. This is for backwash. If you open this, the water which is stored here gets backwashed and goes out. This is valve you see, this is for the backwash. This is a typical, this is a large catchment. Okay, this is another 2-chambered filter where you can see the design here. Okay, you can, suppose if you don't have the space, you can do the same thing underground. Settling tank also can go underground. The entire filter can also go underground. Only problem underground is the water which actually gets stored in this tank, there is no place for it to actually get discharged. So you need to have some soak-away pipes for the water to go down. This is how a typical underground filter looks like. This is how the finished filter. See, this is a sill trap or the first air separator. Then 2 chambers, then goes into the sump. You can see here, it's the same thing. This is the finished thing. It's in a RAS residential complex in Bangalore. Okay, this is how the water gets filtered and gets into the sump. Okay, so any questions on filtration?
Not yet. I don't see more questions right now.
Okay, okay, fine. So, so assuming that this is briefly understood. Okay, we'll just take a quick case study. I know I'm running short of time, but I'll try to finish in about 5 minutes. So, I will give you some hypothetical case. Okay, so assuming they have about 745 square meter of roof area, this is going to be the rainfall. Annual runoff is so much. And I've also given you how many households that they have. They've got 34 houses in that apartment. In that community, so 34 houses spread over 745 square meter of roof area, which receives an annual runoff of 602 kiloliters. Okay, this is how I computed. I computed from the last session formula. I used that 3 variables and got this data. Okay, I'm just giving you a case study because people will be interested in what the ROI and things like that. So now for this area, I've got so much water. So this is a typical BOM. For this kind of an apartment, what are the material which goes into this? Okay, this I think will be shared. I'm sure there's some spelling mistakes here, but please bear with me. But assuming it costs you about 1,67,000 to install this system. Okay, for this kind of a roof area, you're spending this kind of a money. What will be my ROI? I have given you very, very simple calculation, no NPV IRR, but a simple ROI. Okay. Now you look at, they've got 34 houses. Okay. So assuming water demand of 135 kiloliters per person per day, and assuming 4 people per house, their daily water demand is so much. Okay, that is 135 into 4 into 34. So that is 18 kiloliters. Monthly demand is that into 30 is 550. Cost of production, this is actually actual numbers because they are buying from water tanker 110 rupees per kilo. They are spending so much money. So monthly they are spending 60,000 rupees. So yearly they are spending 7,27,000 only on water. So now number of days served by rainwater. So that is 32. How do I get 32? 32 divided by 18. Okay, that will give me number of days served by rainwater. So quantity of water saved is 602 kiloliters. How much are they saving? So if they actually install this system, for 672 kiloliters, they would have spent 66,000, which they are actually saving. Now the cost of the system, as from the previous slide, is 167,000. Rate of interest 8%, and O&M every year they will have to spend on the maintenance about 1,500 rupees. Okay, so this is the O&M. So what is the cost at the end of 3 years? Okay, so you compute what will be the cost incurred at the end of 2 years. That is simple interest. You put simple interest. 167,000 is the capital cost. Plus interest cost has come to so much. How much has they saved in 3 years? 237. So they actually save about 11,000, assuming no escalation in cost. Okay. For this community, for this kind of a catchment, their is 3.5 years, assuming no escalation in cost. Okay. There's only to drive home a point. A lot of people ask me, is this worth investing the money? But I will actually tell you, this is how it doesn't make any sense. You will not, there's nothing called as return on investment for water. Okay, but there's a large something called return on lack of investment. Okay, so if you don't invest on physical infrastructure, we can suppose assume a situation where there is no water to drink or no water in the first tanks. Okay, that is the true return on lack of investment. Okay, so it's the basic need. Nobody will ask you like what is the suppose you get a liter of water to drink. Nobody will ask you what's the return on investment. You're trying 1 liter of water, so what's the return on investment? Okay, that's not the way actually has to be looked at. But even for those people who are actually interested in this kind of calculation, I just put this slide. So dry water pond even is economically also more feasible. Just not about an ROI. It makes a lot of sense. Even if you take the NPV or IRR, it's even better. This kind of calculation because it takes a lot of time. But essentially, this is what it looks like in terms of numbers. Okay. So I will just maybe I will play this video. Okay, you can see this video. Maybe this you get some idea of what I'm talking about.
मैंने उसको 10 ही बोला, मेरे पास 10 लिखी है, तो जब भेजी थी है बाहर तो 10 ही डलवाऊंगा। वो भी करो, मैं बोलो 11 बजे से 7:30 एक ही तो मौका होता है हमने इस बार सही करी है उसको पहले नहीं तो फिर वही टाइम जब वहाँ जा ही रहा है तो खरीदवा दो यार सारे आप ये रखो क्यों भाई सारे इशू कर रहे हैं ना यहाँ पे आप भी रखो की आवाज बिल्कुल खराब आ रही है, बंदे की सुनील महसूस की। या तो बंद कर दो इसको यार। इससे अच्छा बंद ही कर दो, लाइव भी जा रहा है ना फीड। म्यूट कर दो इसको एक बार। अभी भी उधर क्या गया मैं कह रहा खोल लो क्या फर्क पड़ रहा आपको कह रहा हमें तो मिलेगा आप खोल तो सही मिलेगा तो आप क्या जा रहे हैं खोल लेते 5 बच्चे मिल रहे हैं तो आपको तो मिल ही रहा है ना जेल से ढूंढना जा रहा है
Sunil, I think Sunil, I think there's a problem with the streaming of the video.
Sorry?
Yeah, the first one also and this one also, it's actually breaking and coming.
Okay,
I can ask the participants to view those videos
yeah.
separately.
So what all the entire thing I explained here actually go to the video.
Yes, thank you. If you can share these two YouTube links with me, I will forward it to all the participants so that they can view it.
Okay. Okay, fine. So there is there in the presentation also. You can just take it and share it. Should I put it in the chat link?
Yeah, if you can put it in the chat link, that will be wonderful.
Yeah, I just do it. Just a minute.
मशीन खोल दें जो 10-15 लोग आते हैं पी लेंगे अपना जब चाहिए अब बस वही है मैंने बस इनके नाम प्रोटोकॉल बना लेते हैं कि बस इनके बगल पे एक सैनिटाइजर रख लो बस इनका हाथ मशीन उसको दिया अकेले से वो लाके देने तो बड़े अलाउ टू अदर देन यार ये भी तो बीर है मैं कह रहा हूं कितना ऑथराइज कर दो मशीन से चक्री से जाके चाहिए ला सकता अकेले से वो ला दे देंगे बना बात कर दो ना वो तो वैसे भी हमको भी तो बाहर से लाकर खरीद दे रहे हैं यस मैं क्योंकि आज चाय तक नहीं सारा खराब जल्दी भी ना जाएगी मैं तो फिर भी तुम्हारी और देखा ग्रीन टी डॉक्टर भी मैं तो बाहर से लाने जा रहे हैं बाहर में मैंने तो बोला मैंने कहा डॉक्टर से कह रहे सर बाहर भी नहीं है आज ये वाला तो साइड है यार यही बोलना पड़ेगा इधर वाला बोलना पड़ेगा
Sunil, we can't hear you. You are there.
I'm just give me a minute. I am putting this video.
Okay.
सही बोला रामकृष्ण बहुत शार्प है कमेंट आ रहा है सटीक कमेंट आता ना उसका
मैम ये लाइव फीड बंद फेसबुक लाइव बंद कर दूँ भी चलना है
वो जो कमेंट आपको देगा ना वो दूसरे को भी दे देगा
अच्छा ठीक है ओके ओके